Hi students, now we're going to be going into the second part of topic 14, which is about linear equations and two variables. Part 2 is going to consist of all the algebraic work. The first thing we're going to look at is the slope of a line, which in math we always denote as m. So m, our slope, is actually equal to rise over run, or the change in y divided by the change in x. So we're looking at y2 minus y1 over x2 minus x1, and this is given 2 points, x1, y1, and x2, y2. So if I wanted to find the slope between 2 points, in this case 6, 10, and 4, -2, what I'm going to do is just determine where my x1, y1, x2, and y2 are, and then plug it into my formula. Okay, so I'm just going to call this x1, y1, and x2, y2. And plug it in. So my slope is going to be equal to y2 is -2 minus y1, which is 10, over x2, 4, minus x1, 6. So whenever you're doing this, you want to just, it doesn't matter which one is x1, y1, which one is x2, y2. It just matters that they're consistent. So we have 4 and -2. It should be 4 and -2 on top of each other. 6 and 10. And then we have 6 and 10 on top of each other. Okay, so they should be aligned. Right here. Okay. Simplifying this, I know that -2 minus 10 is equal to -12. 4 minus 6 is -2. So my slope is +6. We're still going to be working with the different forms of linear equations as we discussed in the first video. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Point-slope form is y minus y1 equals m times x minus x1, where m is the slope. And we have the point x1, y1. Standard form is ax plus by is equal to c. Okay? And just a quick reminder, the only things that I'm going to change out are let's see if I can highlight this, m, b, y1, x1, and m. And a, b, and c. The x and y should always stay in there. Your equation should always have your x or y. Now we're going to look at identifying certain things when only given an equation. So looking at this first one, y equals 2 over 5x minus 4, I can tell right away this is in slope-intercept form, and it's easy for me to identify these things in slope-intercept form because it's just my m and b, right? So since this is in slope-intercept, this is my m and this is my b. So my slope is 2 over 5, and my y-intercept is -4. Okay, so slope-intercept form, super easy. This next one, 3x plus 2y equals -6. This is not in slope-intercept form. It's not solve for y. It's not y equals mx plus b. This is in standard form. So what I need to do is actually convert this to slope-intercept form in order to identify my slope and y-intercept. So we're going to be going over in the next page how to convert between the forms, like in this. Okay, so now I'm looking at how to convert to slope-intercept form. Write an equation in slope-intercept form. The questions might also ask you, find the slope-intercept form of the line with so-and-so. So if I'm given this, 3x plus 2y equals -6, this is in standard form, ax plus by equals c. Want to convert it to slope-intercept form. How to convert it to slope-intercept form? We solve for y. Okay, 3x plus 2y equals negative 6. I'm going to subtract 3x, so I'm left with 2y is equal to negative 3x minus 6. Now I'm going to divide everything by 2. So we have y is equal to negative 3 divided by 2. X minus 6 divided by 2 is 3. And so you can see from the previous example, if I was to be given this equation and be told to identify the slope and y-intercept, I can convert it first and then identify it easily from here. I know that my slope is going to be negative 3 over 2. And my y-intercept is going to be negative 3. This next example is in point slope form. Y minus y1 equals m times x minus x1. I'm going to do the same thing again, solve for y, but for this one I have this extra step of distributing. So first I'll just distribute this 3. 3 times x is 3x minus 6. I'm going to add this 4 to the other side. Y is equal to 3x minus 2. This one's easy now. If I wanted to identify my slope and y-intercept, my slope would be 3, my y-intercept would be negative 2. But if I was just told to write the equation in slope-intercept form, this would be my final answer. Well, now we're going to be looking at converting to standard form. So if I'm given this, y equals 2 over 5x minus 3, which is in slope-intercept form, and I wanted to convert it to standard form, I now want to put my x and y to both one side, the left side, and get rid of any fractions. So 2 over 5x, I'm going to move to the other side. I'm going to subtract 2 over 5x. So I have negative 2 over 5x plus y is equal to negative 3. So we don't want fractions. Right now I have 5 on my denominator. I have negative 2 over 5, which is a fraction. In order to get rid of this fraction, I'm actually going to multiply everything by 5. In order to get rid of that denominator. So I'm going to multiply by 5. Also this y, multiply that by 5 also. Multiply this by 5. When I do that, I'm able to keep everything the same, but still keep it to be the same line. Okay, so once I have this, I have ax plus by equals c, x and y are on the one side, and I have no fractions. This is in standard form. So now we're looking at writing equations of lines given certain things. So if I was given a slope and a y-intercept for this first example, I know that the form that deals with slopes and y-intercepts is the slope-intercept form. So I know I'm going to have to use the form y equals mx plus b. And I know that my slope is going to be negative 5, so my m is negative 5. My b is 3, so I can change this to y equals negative 5x plus 3. So if it doesn't specify what form to use, I would just use whatever form is convenient for me, which in this case is the slope-intercept form. Now we see a line, give the equation of the line with slope 2 through 9, negative 1. So I'm given a slope, and I'm given a point right here. So I would use point slope form. Point slope form. So it's y minus y1 equals m times x minus x1. So this is going to be my m. M is going to be 2. Y and x are going to stay there, right? So we have y and we have x. This 9, 1 is going to be my x1 and y1. My y1 is negative 1, so it's y minus negative 1, 2 times x minus 9. Just plugging in whatever I have there. So I'm taking out my y1, m, and x1. In order to simplify this, minus a negative is going to turn into positive. Y plus 1 is equal to 2x minus, you're allowed to leave it there, x minus 9. Again, if it does not specify what type of equation to use, just put it in whichever one is most convenient for you. In the next page, we're going to be looking at when they do specify what equation they want, what form they want. So looking here, write the slope-intercept form of the equation of the line with the same thing. So I already said slope -5, y-intercept -3, y is equal to -5, x plus 3. This is already in slope-intercept form, so we're good. This next one, I'm given a slope and a point. I don't know what my y-intercept is, so I'm not able to put it right away in slope-intercept form. What I'm going to do instead is put it into whichever form I can and then convert it from there into the form that's asked for. So I'm going to actually put this into point-slope form first. Y minus, or y plus 1, we did this in the last slide, equals 2 times x minus 9. I'm going to solve for y. Distribute that 2. We have 2x minus 18. Y plus 1. Subtract 1 on both sides. Y is equal to 2x minus 19. So this is now in slope-intercept form, which is what was requested. Again, put it in whichever form you can put it in, and then convert it to whichever one it's asking for. This example, find the slope-intercept form of the equation of the line through this point and this point, -15, 4, and 10, -6. So now I'm given 2 points. So the forms that we know are slope-intercept form, which I'm given a slope and a y-intercept, a point-slope form where I'm given a point and a slope, and standard form, which I have to solve for using one of the other ones. There is no point-point form for when I have 2 points. So what you're going to do first is find the slope between the 2 points. So whenever you have 2 points, you can always find the slope. We said the slope earlier was m equals to y2 minus y1 over x2 minus x1. If I was to call 15, 4, x1, y1, and 10, -6, x2, y2, my slope can be equal to y2 minus y1. So we have -6 minus 4 over x2 minus x1, 10 minus negative. So minus negative would be plus 15. -6 minus 4 is -10. 10 plus 15 is equal to 20. Simplifying this is going to be equal to -1/2. So my slope is -1/2. From here, I have a slope and I have points. I can choose either of the points and put them in slope-intercept or point-slope form. I'm sorry, I have a point and a slope. I can put it in point-slope form. We have y minus y1. So if I wanted to use 10, -6, my y is -6, so y minus -6, it's the same as y plus 6, is equal to the slope, -1/2, times x minus 10. So this is my x1, y1, this is my slope. From here, it says to put it in slope-intercept form. So what I'm going to do is solve for y. So I'm going to distribute this 1/2, move the 6, and then solve for y. Distribute this 1/2, -1/2 x plus 1/2 times 10 is going to 5. So I have +5, y plus 6, subtracting 6. I'm able to get y equals -1/2 x minus 1. Now this is in slope-intercept form. So again, what you do is find the slope, 2, put in point-slope form, and lastly, convert to slope-intercept. Okay, so the last page now we're going to look at is Find the equation of the horizontal line through 5, -2. So for this one, we're going to keep in mind the graphical approach, graphing lines that are horizontal or vertical. So first of all, what I like to do is imagine, or I'll just sketch where the 0.5 and -2 is. So we have a point, 1, 2, 3, 4, 5, -2. My 0.5, -2 is right here. And I'm going to draw a horizontal line through this point, which is right here. And when I look at this line, can I give an equation of this line? What remains constant in this line? So I'll notice that the y values everywhere on this line are the same. They all have a y value of -2. So that's actually going to help me give my equation of my line. Y is equal to -2. Conversely, we have write the equation of the vertical line now through -7, 9. Same thing again. I'm going to draw it out. -7, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we have a point right here. -7, +9. We're now drawing a vertical line. Oops. Okay, so we have this vertical line right here. You'll notice again, for this vertical line, something remains constant. Everywhere on this vertical line, the x value is the same. The x value everywhere on this line is -7. And that's actually my equation of my line. So that's all for topic 14. Please be sure to check your emails just before class on Wednesday so we can all log in to Big Blue Button, practice doing our conference call, such as we can see how to set up our workstations for testing, which is going to start Friday. We're also going to practice uploading our tests. A practice test for this version is just going to be a piece of paper submitted as a PDF, just to make sure that everything runs smoothly on Friday when we have our testing. Please make sure to check the schedule to see what tests are going to be on Friday. And of course, after that, we're going to have discussion if you have any questions on this topic. Thank you and good luck.